Welcome to Mentivia. In this module, we're exploring how atomic structure can be visualized through models that bring the invisible world of atoms to life. Hi there, I'm Mark from Mentivia. Atoms are incredibly small, making them impossible to see with the naked eye. But by understanding their fundamental components and how they behave, we can build models that help us grasp their complex structure. In this module, we'll explore how these models represent protons, neutrons, and electrons, and how they reveal the organization and dynamics of atomic systems. These visualizations are essential for making sense of chemical behavior and the architecture of matter itself. Let's dive into the unseen world of atoms. At the heart of every atom lies the nucleus, a dense core composed of protons and neutrons. Protons carry a positive charge and define the element's identity, while neutrons are neutral and add to the atom's mass. These particles are tightly bound together, forming the central mass of the atom. Orbiting the nucleus are electrons, tiny negatively charged particles that move at incredibly high speeds. Unlike the fixed orbits often depicted in older models, electrons occupy regions of space called electron shells or energy levels. Their movement is more like a cloud of probability rather than a simple planetary path. Think of electron shells as different energy levels or floors in an atomic building. Electrons prefer to occupy the lowest available energy levels, but they can jump to higher levels if they absorb energy and then fall back, releasing energy in the process. This dynamic behavior is key to how atoms interact. Here you can see a visual representation of the electron's movement. It's not a simple circle, but rather a complex, three-dimensional dance around the nucleus. This constant, rapid motion is what gives the electron cloud its characteristic shape and volume. To truly appreciate the complexity of an atom, we often use 3D models. These interactive visualizations allow us to rotate, zoom, and even sometimes manipulate the atomic structure, providing a much more intuitive understanding than flat, two-dimensional diagrams. Let's delve into what these models highlight. In a 3D model, the nucleus is prominently displayed as the atom's central, most massive component. You can often distinguish between the individual protons and neutrons, appreciating how densely packed they are. This central arrangement is fundamental to an atom's stability and overall structure. Beyond the nucleus, 3D models vividly illustrate the electron shells. These are not solid rings, but rather regions where electrons are most likely to be found. Each shell represents a different energy level, and within these shells, electrons occupy specific orbitals which have unique three-dimensional shapes. These shells are crucial for understanding chemical reactions. In summary, visualizing atomic structure helps us understand that protons and neutrons reside in the dense, central nucleus, while electrons rapidly move in distinct energy shells around it. These dynamic models are essential tools for grasping the fundamental building blocks of matter and how they interact to form everything around us. Thanks for watching. If you found this video helpful, be sure to check out mentivia.com for more educational content. There you'll find completely free e-learnings, videos, and articles designed to deepen your understanding across a wide range of topics. And if you'd like to keep learning with us, don't forget to subscribe to the channel. We've got plenty more coming your way.